Hi, it's just a quick video to show people that I've made a secondary mirror focuser for my 14-inch edge telescope. The problem with the focuser on the edges, if you want to use autofocus, you need to leave the mirror locks loose. So that introduces mirror flop, etc. So I've decided to knock up a Ascom secondary mirror focuser. It uses myFocuserPro2. I don't know if you can see that, but it's Ascom compliant and it will use auto focusing routines. So you can get a basic focus, lock your main primary mirror off, and then this motor will then move this in and out that holds the secondary mirror, which is here. You can see that fits into there. It's locked off with those grub screws. Collimation is taken care of by these screws here. These are push and pull, so similar idea to the collimation on the old one. You screw these in and it'll tip the entire assembly in the housing, so basically tips the mirror inside there to collimate it. The motor is a 1.8 degree 200 step per revolution, and then I've connected that onto a 64:1 reducer, so the motor itself will do 12,800 steps per revolution of the output shaft. Then the output shaft is it's a lead screw that's a 4-start 2mm pitch, so one revolution of the lead screw will move the output 8mm. So the amount of travel I've got on here is 8mm, and it will be 10,000 steps of the motor to move that 8mm. So I'll just show you it operating. You can see the motor's turning there. This is basically pulling the secondary mirror away from the primary mirror. 10,000 steps, it's completed. And then back to 0. Very slowly turning. That's it, back to 0. It's all controllable from the sound pedal as well. So I don't know if you can see that, that's probably too bright. Yeah. Thanks for looking. I'll put a few extra build pictures up. In fact, what I'll do is I'll strip it down and then you can see how it all goes together. If anybody wants to make one themselves. Right, this is taking it apart what I've done so far is I've just taken these 3 little thumb screws out of the ends of these. These are linear bearings, and then silver steel ground shafts that it slides up and down on, so it keeps it perfectly true to the axis that it's moving on. So what you have to do basically is reset the maximum amount of steps so it thinks it's in a different position, and basically wind it apart with the motor, wind the 2 halves apart. So if I set that position to go to 0 and then go to position, now you can see that these shafts are going down through the linear bearings. And it's just winding itself apart. It can't do that once it's all screwed together, because these thumb screws in here hold it together, so there's no chance that it's ever going to come apart and drop your mirror onto your secondary. Not quite enough. That's it. So, you can see that's the main shaft there that connects the 2 parts together. That spring's in there just to take out any backlash that there might be in the assembly. But these shafts are designed for 3D printers and such like, so they're very accurate. And then to put it back together, basically sits on there, and then the beauty of it is it builds itself up. Has anybody ever made out that puts itself together? So I've got to put it in the telescope and get it all collimated up, and then check it out, see what happens. There we go. Just show you this on here as well. That's got it's all temperature compensated as well. If you just type into Google myFocuserPro2, and it's open source, there's all the details on how to build your own. I've made a couple of these now, if you can see that. Temperature compensated. It'll do full, half, quarter, eighth, even up to 1/32 step size. So that'll change that from 12,800. Multiply that by 32 steps per revolution if you want a much higher resolution. But I think it'll be plenty just with 10,000. That's the software. Windows based. So all your Ascom programs will talk to that and operate the motor through it. and that's the observatory that it's going in. I'm going for full automation, that's why I'm doing this with a focuser. I don't want to have to go out and mess about at all. So I made it out of just some bits of alley that I had in the garage, and I've got a little home anodizer going, so I've anodized it all myself as well. I'll add a couple of videos into this just of these parts in the anodizing tank and in the dye tank, just so you can see how they looked.
They've taken them all out of circulation in school class, so nobody needs to worry. But the question is, how many people are actually the victims of this? This acute shortage right at this moment. I'm just going to say, sorry, just to help me understand, obviously it's a gas. Is it transported in gas form or is it liquid under compression? It's basically transported as liquid, so and then transport it in road tankers, just like fuel tankers basically, but more specialised. And they will truck that around the country to, you know, all parts of Scotland down to here in Cornwall. And at what point does the liquid become a gas? When basically they have liquid tanks, storage tanks at customer sites in the main.